Dear students, welcome back again to my next video where we will be dealing with potential difference, EMF, internal resistance, and the relation between potential difference, EMF, and internal resistance. In your chapter 2, already you had studied about potential difference. What is potential difference? Potential difference is the difference of potential between 2 points, or in fact you can say that potential difference is work done per unit charge. If Q is 1 coulomb, then V will be equal to W. Therefore, potential difference is defined as the amount of work done in taking a unit charge from one point to another in a circuit. This is what you had studied, and SI unit of potential difference is volt. Now then, let us study the next topic, that is EMF. EMF, full form, it is electromotive force. What is electromotive force? Is it actually a force? Now let us see. Assume that here we have got a battery. For example, you take for example a dry cell. In case of dry cell, you will have two electrodes, A and B. Now, and inside the battery, electrolytes are there. The electrolytes are in the molten state, made up of ammonium chloride, manganese dioxide, and coke, and the charge carrier there will be the ions. Here, this is just a schematic diagram of a battery. Now, due to non-electrostatic origin charges, there will arise a force which drives all the positive charges towards, which will drive all the positive charges towards A and all the positive charges, that is positive ions, towards B. And due to this force of non-electrostatic origin driving all the positive charges are accumulated there at A and negative charges are accumulated there at B. As a result of that, a potential difference is set up, and at the same time an electric field is set up from A to B. Okay, an electric field has been set up from A to B, and this field exerts a force on the charge Q. So what is the force exerted? The force exerted will be nothing but Q into E, and this is the force exerted by force exerted due to non-electrostatic origin on the charge Q, and at the same time this will also be a steady state will be reached where this is due to electric field, and a steady state will also be reached where the force exerted by non-electrostatic origin will be equal to force exerted due to the electric field. Okay, then in that case work is going to be done. As it exerts a force and a charge, let us suppose that a charge travels from B to A, then what is going to be the work done? Work done is force into displacement, F into D. What is D? D is nothing but the distance between the two electrodes. So this is going to be the work done in displacing the charge from B to A. And work done per unit charge. Work done per unit charge. Here, work done per unit charge. Unit charge, I am going to denote it by E, that is work done divided by charge. Work done divided by charge is Fn into D, that is work done. Force into displacement divided by Q. This work done per unit charge in taking a unit positive charge from the lower potential to the higher potential is termed as what? Is termed as electromotive force. Here, this is the electromotive force. So how will we define electromotive force? We will define electromotive force as the work done in taking a unit charge from lower potential to higher potential. Work done in taking a unit charge from lower potential to higher potential. This is being termed as electromotive force. If the two terminals of the battery are not connected, here this is the two terminal of battery, and this battery is not connected to any external circuit, then under that conditions, if the two terminals of the battery are not connected, battery not connected. Two terminals with battery not connected, then we call it as what? Open. That is open. Okay. Then we will have the force. Force exerted due to non-electrostatic origin is equal to force due to the electric field is equal to charge Q into E. And then work done in displacing the charge through a distance of D, it will be equal to what? It will be equal to Fe into D is equal to QE into D. And ED is, from where you get this one, this is Q into V. Where from where you get this is, you get that electric field is negative gradient of potential VD. Already we had derived this one. Already we had discussed this one. E equal to V by D. Okay, in the chapter number 2 itself. Therefore, from here we get this one, and therefore what we find is that when we divide all this by the charge Q, then we know that F and D divided by Q is equal to QV divided by Q. F and D divided by Q is nothing but EMF. So EMF is equal to V. That means EMF is nothing but potential difference. Potential difference when the circuit is open. So there we can define electromotive force as what? Electromotive force is the difference of potential between the positive and negative terminal of cell when the circuit is open. Okay, this is the definition of EMF. Therefore, EMF, SI unit of EMF is also, as it is difference of potential, SI unit of EMF is also volt. So don't get confused that EMF is a force. It's not a force, it's a misnomer. Okay, it's a misnomer. Actually, it is a potential difference between the positive and negative terminal of cell when the circuit is open. Okay, so now next, what is the difference between EMF and potential difference? Now let us try to find out what are the differences. EMF is difference in potential, I told you, between the two terminals of cell when the circuit is open, whereas potential difference is a difference of potential between the 2 points when the circuit is closed. Now, second point of difference, EMF exists even when the circuit is not closed, whereas potential difference exists only when the circuit is closed. Means only when current flows, potential difference will exist, whereas EMF can exist even when no current flows. Now then, EMF is a cause. Why is it a cause? Because when it is applied to it, the potential difference is cause, means potential difference is developed, and then potential difference is the effect. So we can say that EMF is a cause where potential difference is an effect. Now the next is EMF is always greater than the potential difference, but all the time we will come to know about this one in the next topic which is coming up, relation between EMF and potential. EMF is always greater than the potential difference, but during the charging of cell, potential difference will be greater than the EMF. And the fifth point of difference is that EMF is independent of the external resistance, whereas potential difference depends on the external resistance. These are the 5 points of difference between EMF and potential difference. Now next, let's come to what are the factors on which what do you mean by internal resistance? What are the factors on which the internal resistance of the cell depends? Now here I have got a cell again here, and inside the cell I told you that what electrolytes are being filled, and because of the electric field set off and force due to non-electrostatic origin and force due to the electric field setup, charges will be moving. When the charges, that is the ions, move, they collide among themselves, and an opposition is being offered when the charge moves inside the cell. So the resistance offered by the electrolyte of cell to the flow of current, to the flow of currents means to the flow of electrolyte, to the flow of ions inside the electrolyte between its electrode is called the internal resistance. So internal resistance is nothing but resistance inside the cell which is being offered when current flows, that is which is being offered when ions flows inside the electrolyte in between the two cells of the electrode. That is known as internal resistance. Internal resistance, it is being denoted by small r, and its SI unit is also same as what? SI unit also ohms. Okay, it's actually a resistance inside the cell. Then what are the factors on which this internal resistance depends? Internal resistance depends on number of factors. Number one, the first factor is nature of electrolyte. Nature of electrolyte. And then number two is concentrations of the electrolyte. If the concentration is more, concentration of electrolyte is more, then the internal resistance will be more. Then number three is it's directly proportional to what? It's directly proportional to the distance between the two electrodes. And again, number four, it's inversely proportional to cross-sectional area of area of the electrodes. And then number five, again, it is also inversely proportional to the temperature. Why? Because internal resistance increase with the decrease of temperature. These are the factors on which the internal resistance of a cell depend. Now then, the next topic which I am picking up is, let's try to find out the relation between the internal resistance EMF and terminal potential difference. So here we know that I had taken here a circuit. Here I had taken here a circuit where I have got an external resistance capital R, a cell, okay, a cell having the two terminals A and B. Here it should be like this, but I have shown it. This is complete cell having internal resistance small r. E is the EMF of the cell. Then R is the external resistance, I is the constant current flowing through it. Then EMF is nothing but work done by the shell in carrying the unit charge along the closed circuit, and then this will be equal to work done in carrying unit charge from A to B plus work done in carrying unit charge from where? B to A. So your EMF is work done in carrying unit charge is nothing but potential from A to B, that I am going to denote it by V, plus work done in carrying unit charge from B to A is potential difference within the cell. And from Ohm's law we have B is equal to IR. B dash will be IR, where R is the internal resistance. Therefore E is equal to IR plus I small r. Okay, and then I can take I common. We will have R plus small r. This is EMF, and actually I can also see that I is equal to E divided by capital R plus small r. Okay, but you know that here what I can also write from here is that E is equal to, this is V, I can write it as V plus I small r. This I can write it like this. And another from here what I can write is that E by V is equal to I small r, or small r is equal to E by I can write like this, E minus V. Actually it should be E minus V is equal to IR, or R is equal to E minus V divided by I. And since we have V is equal to RI, I can replace it as R is equal to E minus V by, instead of I can write it as V by R. And therefore what I can do is that R is equal to E minus V by V into R, or this will be equal to, and this can be equal to R is equal to E by V minus 1 divided into R. This gives a relation between internal resistance, EMF, and potential difference.